Today's lesson, we're going to look at midpoint and distance. We want to answer the question, how are the midpoint and length of a segment on a coordinate plane determined? And we have a new vocabulary for this section, which is midpoint, which, as you might have guessed, is just a point that marks the middle of something. In our case, we'll be looking at segments. By the end of this section, you should hopefully be able to use the midpoint and distance formulas to solve problems. The midpoint formula is given here, and they define midpoint of a segment as a point that divides a segment into two congruent segments. Again, congruent, in our case, meaning the same. So a midpoint cuts it in half. So if I look at the example here, I can see that I have the point P at -4, -3, and Q at 2, 1. If you want to find the middle of the segment PQ, you're looking for halfway between the x's and halfway between the y's. And wherever you move on the coordinate plane, you will always be looking for halfway between the x's and halfway between the y's. Now, to find that halfway mark, given 2 points, you can add the two x values together and divide by 2, and that'll give you a new x value for your midpoint coordinate. And likewise, for the y values, you can add them together and divide by 2 to get a new y value. Now, you might remember this better is if you consider it as taking the average of the x's and the average of the y's. Because remember, in order to find an average, once you've added all your numbers together, you divide by how many you added together. So, to find the average of the x's, you add the 2 and divide by 2. To find the average of the y's, you add the 2 and divide by 2. And this is going to give you the halfway point between x and y. So, if I'm looking at their example, trying to find the midpoint between A and B, we want to use the midpoint formula, which, if we remember, is the average of our x values, so their sum divided by 2, and the average of our y values, their sum divided by 2. And given the 2 points, it doesn't matter which one you call x1, y1, or x2, y2. If you're adding them, an order doesn't matter in addition. So here we can see that we take the x values from the points and we plug it in to get that. -3 plus 4 gives us +1/2. Our new x value is 1/2. And doing similar with the y's, plugging them into our formula, we get this. And we can find the average there. 2 plus -2 is going to give me 0. Divided by 2, still going to give me 0 as my new y value. Now, if you want to know whether or not you got the right point, given a figure like this, an easy enough check would just be plot this point. So if I plot 1/2, 0, that's going to be right there on my graph, which, from the looks of it, makes those 2 equal halves. So I'm reasonably confident that that is my midpoint. So again, midpoint is finding the average of your x's to get your new x value, the average of the y's to get your new y value. Now, what if we don't want to go halfway? What if we just want to go 3/5 of the way? In order to find a fraction of a way, or a fraction of the way between these 2 points, we first have to ask ourselves, how far am I going? So, we need to find out my horizontal distance that I've traveled. So from here to here will be my horizontal distance. And if I started at 3 and I end up at 13 for my x's, that tells me that I've gone a distance of 10. Same for the y's. I have to find out how far I've gone up. Well, if I start down here at -4 and I end up here at 11, that means I've gone up first 4 units to hit 0, and then 11 more units. So the total distance I've traveled in the y direction would be 15 units. Now, if I want to find a fraction of something, of is an operative word that tells me to multiply. So whenever you see of, you're taking a percent of something or a fraction of something, you're multiplying that fraction times what you're trying to find the part of. In our case, we want to know what is 3/5 of the horizontal distance. Well, 3/5 of the horizontal distance is 3/5 of 10. Because again, I just found the difference between where I started and where I ended. Mathematically, that looks like an absolute value equation. Or you could just count between points. 3/5 times 10 is going to give me 6. Same thing on the y's. If I want to find 3/5 of the vertical distance, it's 3/5 times 15, which gives me 9. Now, if 6 is 3/5 of 10, and 9 is 3/5 of 15, I need, if I want to know what 3/5 of the way from A to B is, from where I started at A, I need to move horizontally 6 units and vertically 9 units. So, starting at 3, -4, and going 3/5 of the horizontal distance means I'm adding 6 onto 3. And if I want to go 3/5 of the vertical distance, starting at -4, I'm adding on 9. When I simplify that, 3 plus 6 is going to give me an x-coordinate of 9, and -4 plus 9 is going to give me a y-coordinate of 5. And that should be 3/5, or a little over halfway, of the distance between A and B. Again, I can do a visual check if I plot that. So 9, 5 is about there. And from a quick visual check, that is a little over halfway between A and B. I'm reasonably confident that that's the correct answer. So to recap that, in order to find a fraction of a way across a line segment, you have to first find out how far you're going horizontally and vertically. Take that fraction of the distance by multiplying. And once you find out what part of the distance you have to go is, you add those to your starting value. Now we're going to look at the distance formula. Now the distance formula is derived from another famous theorem that you may have heard of at this point, called the Pythagorean theorem. Which says a squared plus b squared equals c squared. And that corresponds to a triangle, a right triangle, where c is always the hypotenuse, and it doesn't matter what the other two sides are, called a and b. You could have them switched, as long as c is the longest side, the distance of the hypotenuse. So if we take this and compare it to our picture we have here with finding the distance between p and q, I can see that this side kind of corresponds to A, and this side over here corresponds to B, where then this side would correspond to C. Now, given a triangle, they're going to tell you what those numbers are that you're using to find the numbers in the Pythagorean theorem. Here, our extra step is going to be finding that distance ourselves. So finding the sides of the triangle is going to be similar to what we did before, where you're finding the difference of where you started in your x and where you ended with the x. So in our previous example, we started at 3 and we ended at 13. That told me the distance I went, the horizontal distance was 10. In the previous example, my y value at start was -4, and it ended up at 11. That tells me that my side of the other triangle would have been 15. So to find those sides, you're just finding the difference of your x's or y's. Now, this formula, the Pythagorean theorem, gives you c squared. But we just want to know the value c. Or in our case, we're going to start calling it d, as they do here, just because we're talking about distance. So if you want to find just that value by ourselves, we need to undo the square on c. And to undo a square, we utilize a square root. Whatever I do to one side, I'm going to do to the other. So the square root of something squared, that cancels it out. So I get c is just the square root of a squared plus b squared. Now, if I translate that to, if I don't know the side lengths, if I only know coordinate points, and I want to come up with a formula, the formula would be the distance between points, sometimes written as d of pq, is equal to the square root of our side A, which, given in points, is x2 minus x1, plus the square of the other side, which has a length of y2 minus y1 squared. And that is the distance formula, which again should be very similar to the Pythagorean theorem. It's what it's based on. The only difference is now in my triangle, I'm not given side lengths, I'm given points, coordinate points. So I have to figure out what is the side length by taking the difference of the x points. What is the other side length by finding the difference of the y points. So let's do one example utilizing the distance formula. We have a diagram of a baseball field overlaid on a coordinate plane, and it says a pitcher throws the ball to the batter. So down to the batter, who hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? And we want to round our answer to the nearest tenth of a foot. So, to find out the distance between the pitcher and the batter, the first thing I need to know is their coordinate points. So the pitcher is located at 5, 5, and the batter is at the origin, or 0, 0, and the shortstop is at 5, 10. Now, using the distance formula, the difference of my x values squared plus the distance between my y values squared, given my 2 points, 5, 5, and 0, 0, I'm going to say the distance between the pitcher and the batter can be found by plugging in their coordinate points into the formula. So I had an x value of 5 and an x value of 0. And same for the y values. I have a y value of 5, a y value of 0. It doesn't matter which coordinate I call x2, y2, or x1, y1, because the only difference between switching those values is whether or not you would get a negative, and then you square it afterwards, which gets rid of a negative anyway. So here, if I simplify this, 5 minus 0 squared is 25. So I have the square root of 25 plus 25. That's going to give me square root of 50. So that's the distance between the pitcher to the batter. Now I need to know the distance from the batter to the shortstop. So the distance between the batter and the shortstop can be found with the distance formula. Again, plugging in those x values, I have 5 minus 0 squared for my two x's. And now I have 10 minus 0 squared for the difference of y's. I have to simplify this. It's going to give me 5 minus 0 is 5 squared. 25 plus 10 minus 0 squared is 100. It's the square root of 125. Now, if that distance is 125, and my first distance was a square root of 50, in order to find the total distance traveled by the ball, I'm going to have to add those two values together. So, my total distance traveled is equal to the first distance, which was the square root of 50, plus the square root of 125. Now, you cannot combine these together and say square root of 175. That is a common mistake. You cannot combine those square roots in the way. So, at this point, I would come to my calculator, and I would just type in that expression, because if we're answering this problem, it wouldn't do to leave my answer as square root of 50 plus square root of 125. I would want to say that the square root of 50 plus the square root of 125 is approximately 18.25. And that's just units. if we see down here, this problem has an extra step. So we've utilized the distance formula as we did in the previous examples. To answer this question, though, it wants us to know the total distance traveled by the ball, and we also have to take into consideration that one of these units, or one square, represents 9 feet. So to finish this problem up, I have to take that answer, and I have 18¼ units. I need to multiply that by 9. And it wants us to round to the nearest tenth of a foot. So this times 9, to get our conversions into feet, is going to give me 164.2626693 feet. Rounded to the nearest tenth means I want to round to this place, and the 6 tells me to round up. So my final answer is approximately 164.3 feet. So hopefully now you know how to utilize the distance formula. Again, you're plugging in those coordinates values into the formula. Same with the midpoint formula. You're finding the average of the x's and the average of the y's. And again, I'm available for the first half an hour before school and after school. If this material is difficult, I encourage you to come in and ask for help.